if the arithmetic mean between A and B is twice as great as the geometric mean, so that A is to B is 2 plus V3 is to 2 minus V3. So let us say we have two numbers A and B. So what is the arithmetic mean going to be? Arithmetic mean is going to be A plus B divided by 2. And what will be the geometric mean? Geometric mean will be square root of AB. Now, it is given that arithmetic mean is twice the geometric mean, so what we know is that A plus B divided by 2 is equal to 2 times square root of AB. So, this implies that A plus B should be equal to 4 times square root of AB, and this means that A plus B square, or A square plus B square plus 2AB should be equal to 16 AB, and therefore what we get is A square plus B square minus 18 AB is equal to 0. And now I divide this entire equation by B square, because B square is not 0, okay? So what we get is, if you divide this entire equation by B square, you will get A square by B square plus B square by B square is going to be 1 minus 14 AB by B square is going to be minus 14 A by B is equal to 0. And now I can say that, let us say that A is to B is x, okay? Let A is to B be x. So this becomes x square minus 14x plus 1 is equal to 0, and this is the quadratic equation that we can solve using the quadratic formula, which is x is going to be minus b, which is 14, plus minus 14 square is going to be 196, minus 4 times e times c is going to be 4, divided by 2, right? So this comes out to be 7 plus minus, this is square root of 192, which is actually 192 can be written as 64 times 3, so this is going to be equal to 8 divided 8 times square root of 3 divided by 2. This will be equal to 7 plus minus 4 square root of 3. So this is what our answer is. Our A is to B, our A is to B is either equal to 7 plus 43, or A is to B should be equal to 7 minus 4 root 3. Right? Now let us see what we wanted to prove. We wanted to prove that the question asked us to prove that this should be equal to 2 plus square root of 3 divided by 2 minus square root of 3. And if we rationalize this expression, we will find that A is to B is actually equal to, I multiply the numerator and the denominator by square root of 2 plus square root 3. So this becomes 2 plus square root 3 square, and 2 plus square root of 3 to minus square root of 3, and after rationalization I get that this value should be equal to 4 plus 3 plus 3 times 2, 4 times 2, 3, divided by a square, which is 4, minus square root of 3 square, which is 3, and therefore this will be equal to 7 plus 4 root 3 divided by 1. So we see that our a by b is actually equal to one of the values that we are getting from here, which is over here. So what is the meaning of the second value, which is 7 minus 4 root 3? Remember that we have performed the squaring operation over here, and whenever we square, there is some redundant values that are added, but in this case there is a significance of a is to b, which is 7 minus 4 root of 3, because instead of dividing a square plus b square minus 14ab by b square, we could have easily divided this equation by a square, and then in that case we would have got b square by a square minus 14b by a equal to 0, and we would have got the same answer, that b is to a is going to be equal to 7 plus 4 root of 3. So what it effectively means is that we are actually getting two answers, which is if a by b is 7 plus 4 root 3, then b is to a should be equal to 7 minus 4 square root of 3. And similarly, if a to b is actually 7 minus 4 square root of 3, then b is to a should be equal to 7 plus 4 square root of 3. And it is very easy to verify. Suppose, let us just for a moment assume that a is to b is 7 plus 4 root of 3. Then in that case, it means that b is to a should be equal to 1 divided by 7 plus 4 root of 3, and if you rationalize this, you multiply this by 7 minus 4 root 3 in the numerator, and 7 plus 4 root of 3 times 7 minus 4 root of 3 in the denominator. You end up getting 7 minus 4 root of 3 divided by 7 square is 49 minus 4 root of 3 square is 16 times 3 is 48, which is equal to 7 minus 4 root of 3, which is exactly what we said here. So I hope you understand why we are getting two values of the ratio a is to b. It is actually trying to tell you that a is to b is either 7 plus 4 root 3, in which case b is to a is 7 minus 4 root of 3, but a is to b could as well have been 7 minus 4 square root of 3, and in that case b is to a would have been 7 plus 4 square root of 3, and we are done. This is problem number 19. Find the sum of n terms of the series where the rth term of that series is 2r plus 1 times 2 to the power r. So let us, so we can denote our series as summation of 1 to n 2r plus 1 2 to the power r, and if we expand it, what we get is that s is going to be, let r is equal to 1, so you get 2 times 1 plus 1, which is 3 times 2, plus if we let r is equal to 2, we get 4 plus 1 5 times 2 squared, which is 4, plus r is equal to 3 will be 7 times 8, and r is equal to n is going to give you 2n plus 1 times 2 to the power n. Now you can easily see that this is an arithmetically geometric progression, because 3, 5, 7, 2n plus 1, they are in arithmetic progression. They are odd numbers starting from 3. And 2, 4, 8, 2 to the power n is a geometric series with the first term as 2. So let us multiply s by the common ratio, which is 2, so you will get 2s is equal to 3 times 4. So I will write 3 times 4 below the second term of the series. So this is 3 times 4 plus 5 times 8, and over here it will be the n minus 1th term. So this will be 2n minus 1, and 2 times n minus 1, so it will be 2n minus 2 plus 1, so you will get finally 2n minus 1 to the power n plus 2n plus 1 to the power n plus 1. And now we subtract f minus 2f, so you get minus f is equal to 3 times 2 is 6 plus, I can take 4 as the common factor out, so this becomes 4 times 2 plus, I can take 8 as the common factor out, so it becomes 8 times 2 plus, I can take 2 to the power n common factor out, and this becomes 2n plus 1 minus 2n minus 1, so it will be 2n becomes 2n plus 1, and minus of minus 1 will become plus 2, so you will get 2 again minus 2n plus 1 to the power n plus 1. Now this means that I can write this as minus f is equal to 6 plus, I can see 2 here, so I can take 2 times 4 as a common factor, you will get 1 plus 4 times 2 is 8 plus, and over here you will get 2 to the power n minus 2 minus 2n plus 1 2 to the power n plus 1. I hope you are able to understand what I am doing here. I am trying to take 4 times 2 as common factor out, so this becomes 1 plus, over here I have 8, so 4 times 2 is 8, and over here you have 2 to the power n plus 1. If I take it as a common factor out, you will be left with 2 to the power n minus 2. So this will be equal to 6 plus 8 times. Now this is a geometric progression that we can easily add. Okay, this is a geometric progression with how many terms? It has n minus 2 plus 1 term, so which is n minus 1 term. So this is a, which is 1 here, 2 to the power n minus 1, which is the common ratio and the number of terms, minus 1 divided by 2 minus 1 minus 2 to the power 2n plus 1 times 2 to the power n plus 1, and all we have to do is simplify this. So this becomes minus f is equal to 6 plus 8 times 2 to the power n minus 1 minus 1 minus 2n plus 1 2 to the power n plus 1, and if you multiply minus 1 both sides, this is equal to 6 minus 6 minus 8 times 2 to the power n minus 1 is 2 to the power n minus 1 plus 3, which is actually equal to 2 to the power n plus 2, and this becomes plus 8 plus 2n plus 1 times 2 to power n plus 1. What I've done is just multiplied minus 1 on both sides, so 6 becomes minus 6. This was 8 times 2 to power n minus 1, so now this becomes 8 minus 8 times 2 to power n minus 1, and this will actually be equal to minus 2 to the power n minus 2, and therefore f will be equal to finally 8 minus 6 is 2 plus 2n plus 1 2 to the power n plus 1 minus 2 to the power n plus 2. If you want to simplify it further, maybe we can write this as 2 plus, I can take 2 to the power n plus 1 as a common factor out, so this will be 2 to n plus 1 minus 2, and this will be equal to 2 plus 2 to the power n plus 1 times 2n minus 1. And I think this is simple enough. So our sum is actually going to be 2 plus 2 to the power n plus 1 times 2n minus 1. Let us try to see if our answer is correct. Suppose n is equal to 1, then I get 2 plus 2 to the power 2, which is 4, times 2 minus 1, which is going to be 6. So you can see that at n is equal to 1, I get f is equal to 6, right? At n is equal to 2, this will be equal to 2 plus 2 to the power 3, which is 8, and then 2 times 2 is 4, minus 1 is 3, so 3 times 8 is 8 times 3 is going to be 24, wait a minute, 2 to the power n plus 1 is 8, times 3 is 24, 24 plus 2 is 26. So if I add 2 terms, I should get 26, which is 5 times 4 is 20, plus 6 is 26. And at n is equal to 3, you can see that this will be equal to 2 to the power 3 plus 1 is 4, which is 16. 16 times 5 is 80, and 80 plus 2 is 82. So f will be equal to 82. And let us see if it is coming out to be 82. We know that this is 2 times are 26, and 26 plus 56. 26 plus 56 is going to be 82, and therefore our answer is correct. And this is how we can find the sum of n terms.